Hi guys, okay, so consider an ordered triple, xyz, where each value is a perimeter of a different triangle with integer side lengths. X is the perimeter of a right triangle, y is the perimeter of an isosceles triangle, and z is the perimeter of a scalene triangle. There is only one such ordered triple A, B, C, where A, B, and C, A plus B plus C is equal to 50, and A is A over B and A over C are integers. Find A, B, C. So B must divide A, and C must divide A. So, okay. We know that A, B, and C individually must be less than, well, let's say this is 3, that's 6, must be less than 44. I guess less than or equal to. No, less than, because the smallest you could have is 7. Um, so both are less than or equal to 43. Okay, let's find all the right triangles that work. The perimeter must be less than 43. Okay, so right triangles, there's 3, 4, 5, which sum to 7, 5 is 12. You could also multiply this by 2, 6, 8, 10, which sums to 24. Multiply this by 3, 9, 12, 15. This sums to 36, and that's it. Do we have anything else? We have, I know there's one with 11, right? There's 11, 11 is 121, 121 to 169 is 8, 48, no, 121 to 144 is 23, I think. 121 to 15 squared, 225 is 104. Um, hmm. Okay, well, y is the perimeter of an isosceles non-equilateral triangle, and z is the perimeter of a scalene triangle. So, huh. How do we figure this out? I think going with the right triangle is the way to go, because isosceles perimeter can be anything, scalene perimeter can be anything. Um, okay, so let's try, let's say a is equal to 12. Then that would mean that b plus c is equal to 38, which would mean, let's find a b value that works. Oh, both b and c need to divide a, which means that b and c must be less than a. B and C must be less than A, which means, okay, so A has to be pretty large. So let's say 24 is 12, 12, 12, 24 is less, so let's say A is equal to 36. Then the factors of 36 are 1, 2, 3, 4, 6, 6, um, 9, 12, 18, 36. This is out, okay, these can work. I guess, I mean, it could be 36. Oh no, yeah, it could be, technically, maybe it could be 24 of a different triangle with integer side lengths. I guess 24 could work. A is equal to 24, then either B or C has to equal 24. 24 plus 24 is 48, then we could just have 2. So A is equal to 24, B is equal to 24, C is equal to 2. I think that works. Let's see why this doesn't work. So 36 minus, 50 minus 36 is equal to 14, so this is out. But we could have these two, I think, 12 and 2. Can't we have 36, 12, and 2? We can't have 2. That doesn't work, because it needs to have integer side lengths. Can't have 2. So this doesn't work. We can have 3 though, so if it's not 12, because that would need 2, then 14 would need 5, 6 would need 8, 4 would need 10, 8 does not work, 3 would need 9, which works. No, 3 would need 11. 4 would need 10, 6 would need 8, 9 would need 5, 12 would need 2. Hmm. Hmm. 36. A is 36. Which is it? 20, yeah. Then B plus C would have to equal 14. 14 can be achieved by 12 plus 2, 4 plus 10. Yeah, no. Okay, so, we need to find another pattern of right triangles. Of Pythagorean triple. A squared plus B squared equals C squared. So A squared plus B squared is equal to C squared. We could say B squared is equal to C plus A, C minus A, maybe? Okay, so that's just either two odd or two even numbers, right? Yeah. So 4 must divide B. I lied. So, two different odd numbers or even numbers that multiply to a square. So for 25, that's B squared 25, or no, it'd be 9 squared is equal to 9 times, what? Yeah, 9 times 1. 121 is equal to 1 times 121. That's really large. Hmm. You could say it's 36, 49. Can you say 49 is equal to 49 times, no, because then you need, yeah, sure, 49 times 1. So this is equal to 20, what's the midway between these two? 25 plus 24 times 25 minus 24. So 7 squared plus 24 squared is equal to 25 squared. Okay. What's the sum here? Sum is greater than 50. I think there's one with 13. 13 and 12 maybe? 169 minus... Yeah, that's 25. So 13, or 12 squared plus 5 squared is equal to 13 squared, which means the perimeter here, sum is 25 plus 5, 30. This can work. 60 can't. So we have 30. 30 goes into 1, 2, 3, 4, 5, 6. Not 4. 3, 5, 6. 10, 15, 30. So 30 won't work as 1. 1, 2 can't work. So we just need to find 2 that work. So 30 minus 15 minus 15. 30 minus 10 minus 20, no. 30 minus 6 minus 24, no. 30 minus 5 minus 25 minus 27. 15, 15? Yeah, okay. I think this works. 30, 15, 15. No. What? Am I stupid? The remainder is 20. 15 and 5. 15 and 5. Because here we get 10 and 10. Here we get 6 and 14. Here we get 3 and 17. I don't know why 10 and 10 doesn't work though. 30, 10, and 10. Can I find a scalene with 10? With 5? Can I find a scalene with 5? We need 2 small things that add up to a big thing, so 1 plus 2. 2 small things that are greater than a big thing. 2, no. 1 distinct side lengths, no. The 2 side lengths must be greater than the other one. So 1 which are greater than them individually. So 2, I think it has to be 30 and 10 and 10. 30 times 10 times 10 is equal to 3,000. Let me check. I did not get it right. It was this one here. Not sure why this one didn't work, but anyways, yeah, thank you for watching. I'll see you guys tomorrow. Bye.